In this video, we'll talk about matrix addition and subtraction, as well as how to multiply a matrix by a number, also called scalar multiplication. Let's start with an example. Given two matrices like these, let's say I want to add them together. How do I do that? And so what does addition of matrices means? It turns out that if you want to add two matrices, what you do is you just add up the elements of these matrices one at a time. So my result of adding two matrices is going to be itself another matrix. And the first element I get just by taking 1 and 4 and multiplying them and adding them together. So I get 5. The second element I get by taking 2 and 2 and adding them. So I get 4. 3 plus 0 is 3, and so on. I'm going to stop changing colors, I guess. And on the right is 0.5, 10, and 2. And it turns out you can add only two matrices that are of the same dimension. So this example is a 3 by 2 matrix because this has 3 rows and 2 columns, so it's 3 by 2. This is also a 3 by 2 matrix, and the result of adding these two matrices is a 3 by 2 matrix again. So you can only add matrices of the same dimension, and the result will be another matrix that's of the same dimension as the ones you just added. Whereas in contrast, if we were to take these two matrices, so this one is a 3 by 2 matrix, so again 3 rows, 2 columns. This here is a 2 by 2 matrix. And because these two matrices are not of the same dimension, this is an error. So you cannot add these two matrices, and their sum is not well defined. So that's matrix addition. Next, let's talk about multiplying matrices by a scalar number. And a scalar is just maybe an overly fancy term for a number or a real number. Right? The scalar just means real number. So let's take the number 3 and multiply it by this matrix. If you do that, the result is pretty much what you'd expect. You just take your elements of the matrix and multiply them by 3 one at a time. So 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. And let's see, I'm going to stop changing colors again. 0 times 3 is 0. 3 times 5 is 15. And 3 times 1 is 3. And so this matrix is the result of multiplying that matrix on the left by 3. And you notice, again, this is a 3 by 2 matrix, and the result is a matrix of the same dimension. This is a 3 by 2. Both of these are 3 by 2 dimensional matrices. And by the way, you can write multiplication either way. So I had 3 times this matrix. I could also have written this matrix 1, 0, 2, 5, 3, 1, right? I just copied this matrix over to the right. I can also take this matrix and multiply this by 3. So whether it's 3 times the matrix or the matrix times 3 is the same thing, and this thing here in the middle is the result. You can also take a matrix and divide it by a number. So turns out taking this matrix and dividing it by 4, this is actually the same as taking the number 1/4 and multiplying it by this matrix, 4063. And so, you can figure the answer. The result of this product is, 1/4 times 4 is 1, 1/4 times 0 is 0, 1/4 times 6 is, 3 halves. That 6 over 4 is 3 halves, and 1/4 times 3 is 3/4. And so that's the result of computing, this matrix divided by 4. That gives you the result. Finally, for a slightly more complicated example, you can also take these operations and combine them together. So in this calculation, I have 3 times a vector plus a vector minus another vector divided by 3. So just make sure we know what these are, right? This multiplication, this is an example of scalar multiplication, because I'm taking 3 and multiplying it. And this is, another scalar multiplication, or I'm going to write scalar division, I guess. This really just means 1/3 times this. And so if we evaluate these two operations first, then what we get is this thing is equal to, let's see, so 3 times that vector is 3, 12, 6, plus my vector in the middle, which is a 0, 0, 5, minus 1, 0, 2/3, right? And again, just to make sure we understand what's going on here, this plus symbol, that is matrix addition, right? Already, since these are vectors, remember vectors are special cases of matrices, right? This, we can also call this vector addition. And this minus sign here, this is again, matrix subtraction. But because this is a n by 1, really a 3 by 1 matrix, that this is actually a vector, so this is also vector. Just call this matrix a vector subtraction as well. Okay? And finally, to wrap this up, this therefore gives me a vector whose first element is going to be 3 plus 0 minus 1, so that's 3 minus 1, which is 2. The second element is 12 plus 0 minus 0, which is 12. And the third element of this is, 6 plus 5 minus 2/3, which is 11 minus 2/3, so that's 10 and 1/3. And I'm going to close my square bracket. And so this gives me a 3 by 1 matrix, which is also just called a 3-dimensional vector, right? Which is the outcome of this calculation over here. So that's how you add and subtract matrices and vectors and multiply them by scalars, or by real numbers. So far, I've only talked about how to multiply matrices and vectors by scalars, by real numbers. In the next video, we'll talk about a much more interesting step of taking two matrices and multiplying two matrices together.